Hello everybody, it's Kitty Morgan, the Crazy Math Nerd, back again to talk a little calculus with you today. And we're going to talk a lot about f prime, who we have called the slope of the tangent line, the derivative, dy dx, f prime of x. We've talked about instantaneous rate of change. And so we're going to talk about the first and the second derivative and how they all relate to each other with the original. Okay? So let's start with my favorite swoopy little function. I don't know why I like this little swoop. I always have. This little swoop, excuse me. And so the question asks, what does the slope of the tangent line tell me about the y values of the original? So I'm going to just draw some tangent lines, and I'm going to cheat and use my little line feature because I cannot draw a straight line. I try. Ooh, and this is even dashed. I don't really like that, but I'm going to change it. That's okay. Not that terrible. So let's make it solid. So let's draw some tangent lines to the graph here, just at different points. And let's talk a little bit about what does it mean and what is the graph doing there. All right. So I noticed that if you look at this line is a positive steep line. And it says, what does it tell you about the y values of the original? Well, when you have a positive slope, what is happening to the y values? Are they getting bigger or smaller? Well, it looks to me like they're getting larger. So I'm going to say when f prime is positive, then f of x is getting bigger. And the way we say getting bigger is increasing. The y values, which f of x is y, is increasing. Okay? And notice that still increasing, slope is still positive, slope of the tangent line. And as we go through this, the slope is still positive, and it's positive actually all the way through. We call this a strictly increasing function because see how it's increasing all the time? All right, let's draw a different kind of graph. So let's have some of this going too. Okay, so I'm going to get a different color. And actually I'm going to do another page. Let's do that. And I'm going to get another color. I'm going to do green. So, oh, that's increasing. Oh, I have a little bit. All right. So let's look at that. Let's look at some slopes and some tangent lines there. So that looks just like our other one, right? It looks positive. But oh, there's something crazy happening right there that wasn't happening in our last one. And oh my goodness, look what's happening there. That's a hard tangent line to draw. There's another little crazy thing happening right there. Let me undo that. I didn't quite get close enough to that. There we go. Well, crazy woman. Sometimes if you just draw from the center, that's supposed to be 0, sorry. And then we're going to do that positive again. All right, so as the slopes change, the y values are changing, okay? So notice that when the slope is positive, the slope of the tangent line is positive, the function is increasing. What happens when the slope is flat? Oh my goodness, that's a very important point on a function right there. That's a 0 slope. When it is negative, the y values are going down or decreasing. So when f prime is positive, f is increasing. And we do some little shortcut things for you. And when f prime is negative, then f of x is decreasing. You probably already talked about that throughout some of the stuff when you did your derivative unit, but just kind of trying to make sure we kind of look at that. And when f prime of x was equal to 0, see how that slope is 0? Then we have a possible, this is called a maximum. See, that's the top point. It's the maximum point closest. For all the points closest to it, it's the biggest one. We call that a local max. And then, or it could be a local min, and that's what you call that little point that's that little dip right there. So it's a possible max or min. And the reason I say possible is because there's one more situation that we're going to look at in a minute, and some things have to change. Have to happen. Notice that when you have this maximum, you're going from positive to negative, and then you go from negative to positive. So when these signs change around the zero, we have these max or min happening. Okay? All right, so I think we're ready to fill in our notes now. So this is number 2, and the biggest thing about doing number 2 and talking about all of this is that you're going to have to be able to translate symbols into words that mean something to you. All right, that's the biggest thing you have to do. So number 2 says, what does the first derivative f prime of x tell me about the original function? Well, we've kind of talked about that already. We're going to put that in words, okay? So it says, if the first derivative is positive, and then I wrote in symbols what that means. So when you see this symbol, you're going to think the first derivative is positive. That's what that means. Greater than 0 means positive. So if the first derivative is positive, it says tell me about the original, then f of x is, what did we say that was? That's right, increasing, is increasing. And if the first derivative is negative, again, I put the symbol there because you're going to have to see the symbol and translate it into those words. That's real important for you to be able to do that. So if the first derivative is negative, then f of x is decreasing. All right, very good. This is not hard. And we already kind of talked about this a little bit. And here's, here we go. If the first derivative is 0 and changes from positive to negative around the 0, and that means it goes from increasing to decreasing. So let's think about a graph. Increase to decrease. That's going to be that relative min. Then f of x has a relative minimum. Relative minimum. And we call it a relative minimum because it is a I'm sorry, I said minimum. I meant maximum. So sorry. It's a relative maximum. I drew the graph and everything. Crazy woman. It's a relative maximum. When you increase positive slope to decrease negative slope, and sometimes when I read this, I'll take my hand and go increase, decrease in the air and make that little, and then I can see that maximum kind of with my hand. Relative maximum, because relative to the points around it, it is the biggest one. So let's kind of do the same thing for the next one. If the first derivative is 0 and changes from negative to positive, that's negative slope to positive slope, then we're going to have that minimum. So f of x has a relative minimum. There we go. A relative minimum. Okay. So again, sometimes when I'm doing this to help me, minimum, I can do this. I'll take my hand and go decreasing, increasing, and that helps me see that minimum. That helps a lot. Then in E it says, well, what happens if the first derivative is 0 but does not change signs around the 0? So let's look at an example of that. So let's say I'm increasing and then get a 0 slope and then increase, like an x cubed. Then there would be kind of a 0 slope right there, but it would increase throughout. It wouldn't change signs. So we say that is a horizontal, we got to talk about who. F of x, there we go, has a horizontal layout. Horizontal layout. And that means it kind of just lays out there for just a minute and then it's going to continue to go up. Okay? So just because you have a derivative equal to 0 does not mean you absolutely have a max or min. It must change signs around it in order for you to get the max and min. Or it can look like a cubic does and it would have that 0 slope right there at 0. Okay? All right, so that's the first derivative.